In this video, I wanted to show off my Sumo Robot. I entered it in a competition, and it actually did pretty well. So I wanted to show off the code and some of the features that the robot has. In this video, the green robot is mine, the one with the foam. You can see it sees the robot, so it's going forward right now. And here it actually loses sight of the robot, but it sees a black line, so it turns around, sees the robot again, and it goes forward, and it knocks the robot off. The reason for the foam is that the foam actually prevents the ultrasonic sensors from getting an accurate reading, and that's why the other robot falls off in this situation. The blue robot with the wedge isn't actually mine, but I did help write code for it, and the code is basically the same as mine. The wedge actually prevents the other robot from getting any traction in the front wheels, so that helps a lot in this competition actually. And it basically does the same thing as mine. It goes in circles until it sees a robot, and once it does, it goes forward. Here it sees the robot and it goes forward, the other robot can't get any traction. So here I'll show you the features of the robot. You've got a Arduino motor shield on top. It's driving two DC motors, each at 40 RPM, but very high torque. It's run by a 12-volt battery. I've got a red LED here that indicates a line and a blue LED that indicates when it sees a robot. That helped a lot for the coding. I've got ultrasonic sensor here in the front and two photo-resistors which indicate the line, and these blue LEDs on the bottom are here all the time, or on all the time, and they help give more accurate readings for the photo-resistor. This wheel back here just swivels. This is for the motors. Alright, so now we get to the fun part, the code. Up here is just some things that I've named pins for the motor shield. These are for the ultrasonic sensor. I've got the line LED, which is the red one, the ultrasonic sensing LED, which is the blue one, which senses when there's a robot. I've got a long variable here, which is duration, and an integral of distance. I've got the right photoresistor, left photoresistor, and right white, right color, and left color. Here I've defined all the things for the motor shield here, and defined the things for the ultrasonic sensor. Got the LEDs. And here we have right white, which is reading the photoresistor and subtracting 150 by it. So that'll actually set what the color white is, what it defines white as. And that can kind of change depending on what the surface is. So that's why I have this variable here. And the 150 is kind of like the tolerance. A lower number will turn around at more things, and a higher number will be harder to set off, kind of. And then it prints what the color of white is. I've also got a serial begin, of course. So in the loop here, you can see this this part actually sets off the ultrasonic sensor. I didn't actually use a library for this. This is just what works for mine, and it turns it into a value, which is distance, and that's in centimeters. And that's what is defined by this equation here. Then we've got the right color, and it reads the photoresistor, and the left color, which reads the photoresistor, and then it prints it all out. So I've got left photo, right photo, and distance. So in the loop here, I have a couple commands. I have while distance is greater than or equal to 100. I have while distance is less than 15. If left color is less than left white, and if right color is less than right white, and else. So if right color is less than right white, then it says line detected on right, and the line LED goes on, and both brakes engage, so the robot stops, waits a little bit, and then both the polarities, well, it starts turning. So if right color is less than right white, it says line detected on right in the serial monitor. The line LED goes off. Both brakes engage. I give a little bit of time to stop. Then both polarities are high, which makes the robot go backwards. I just engage both brakes and give it some time to go backwards. Then one of the brakes goes off and I give it some time to turn around. And then the line LED goes off. It gets ready to go forward with these things. And I give it a little bit of time to go forward just a bit. And the left color is just the same thing, it just turns the opposite direction. So then while distance is less than 15, I actually have it just going straight forward. Both LEDs are off, and it senses the distance again, but it actually does not sense the color, because if, say, I'm going against a robot and it goes up to a line, but it still has to push the robot off, I don't want the line to stop the robot before it's pushed off, and it still counts even if the robot falls afterwards. So that's why this is does not sense the color when distance is less than 15. But when distance is greater than or equal to 100, which matches the size of the ring that I was in, I'm actually just spinning around here. I sense distance, sense color. I print this all out. Then I have the if left color is less than left white, and if right color is less than right white again, because even when I'm spinning and looking for a robot, I could run into a line. I don't want that to throw me off the ring. And at the bottom here, I have else if nothing else matches. Then it's just going to have both these off, and it's just going to go straight forward, no brakes, full speed, just go straight forward. Alright, so now I'll just do a brief rundown of the code in whole. This is for the motor. This is for the ultrasonic sensor. So LEDs, more for the ultrasonic sensor. These are all for the photo-resistor. Motor, ultrasonic sensor, LEDs, and the color. Then we measure the distance, measure the color, write it all out, while distance is greater than or equal to 100, which contains if, and this if also, and a while distance is less than 15, and if colors, and else. Technically we don't need these two if statements or the else statement, because the while should contain everything, but I still have them in there just in case there's a problem with the distance and for some reason it doesn't measure or something. I wanted the robot to still be able to go forward and avoid lines and stuff. So this is an example of if you didn't have DC motors or didn't want to use a motor shield or something, you could use servos, and to do that you'd have to include the servo library. I named one of my servos right and one of them left. Then I attached them to the pins that they were on. And here I just have the servos going forward. For a continuous rotation servo, going at 0 or 180 will put the servo at full speed in either direction, and the closer the value becomes to 90, that will decrease the speed. This right one was facing forward, so I have it at 0, which makes it go forward. If I had it at 180, it would go backwards. Here, I wanted to stop. I wanted the right servo to continue going forward, but the left one to stop almost completely, but still go forward a little bit, to kind of have a wider radius circle. And here I have the right servo at 180 and the left servo at 0, and that will cause the robot to go completely backwards. Here you can see the robot. Once on, it will rotate until it sees something and go forward. And here, once it sees something, it continues to go forward, and it doesn't stop at the black line because there's no measuring of the color. And here, when it sees a black line, it turns around if the object isn't close enough. Thanks for watching. If you have any questions, just comment down below. I'll try my best to answer them. I hope this helps with your robot project, and thank you for watching.